Hi guys, I hope my voice is clear. And these are the recordings for this is the recording for the CAT 2024 Slot 2 DILR section. We'll go over each set one by one, and we'll try to see what you could have done in terms of some of the details, maybe some other methods you could have used. Let's look at the questions. Question 1 to 4 is based on this kind of networks and paths only. And the question says that the above is a schematic diagram of straight lines and lakes, rectangular shaped clearly. Different points on the walkways are indicated by letters A through P. Fair enough. Distances being OP, ON, OM, MN, etc. are given, and this is rectangle. So if you know one side, you know the other side as well. And what else is given? The only entry exit point is at C. Fair. There are many residents within the gated area. All of them are located on the path AH and ML. All of them are located on the path AH and ML. So, right, these two paths, with 4 of these residences being at AH, M, and L. So these 4 points have one residence each, it seems. The post office is located at P. The bank is located at B. Super. So, because this is where you're going to solve. I'll try to plug in things here. What is the question? What has the question said? P is the post office. B is the bank. This is the entry as well as the exit. And yeah, that's it. I guess the lengths were given. The lengths were PO was 150. ON was 300. NM was 300 as well. LM was 400. EL was 200. And DE was 400. Of course, I can write things on the other side as well, but yeah, I think we'll end up cramping this, so I'm going to avoid, right? It's a rectangle. I don't think it's very challenging. Great. Let's look at the questions. Are we missing something else? Let's go back. Only entry exit point is at C. We've done that. Residences. Residences. We have to mark the residences. The residences are along. So there is one residence here. There is one residence here, and there are residences here along AH and ML as well. And of course, there's a residence at M and there is a residence L. Super. Post office P, bank located at B. Done. Next. Question number 1 says one resident whose house is located at L. Okay, house is located at L. Where is L? Where is L? This is L. Okay, house is located at L. Needs to visit the post office as well as the bank. What is the minimum distance he has to walk started from his residence and returning to his residence after visiting both the post office and the bank? It doesn't really talk about the order, post office and bank. So we can probably visit the bank first if it makes any difference to the total distance walked, because you want to minimize the distance, right? Minimum distance. But you can also visit the post office. So the route ought to be clearly. I think I'm going to mark it and I'm going to rub it hopefully with So KL post office here. Why not take the route KO and then OP and then PI and then IG and then you have to visit the bank, right? And then GB. You can come back from B to G, but you will not be. Doesn't make sense, right? You have to return back to L. So BC, CF, FE, EL, something like that, right? That would make sense. Right. So KL, first of all, KL is going to be 300. Then KO, look, this is 400 here. This is 400. KN is the same as LM. So this route will be 500, the hypotenuse. So that's 500, right? And then you have PO 150, and then PI is 400, and then IJ is 150, GJ is 200. So the hypotenuse is 250, right? This is 250. And then BG 400. You can all add it up once as well. I'm just writing it so that you guys don't have a problem. This is 300 thereafter, 3, 4, 700. 703, 1,000, and 1,000 and 200. Right? That's how I would normally do it. So yeah, that's what it is. Look, what is this? 250, 150 is 400, 448, 800 and 1200, 8 and 1200 is 2000, 2400, 2400 and another 800. 2400, 800 is 3200. That ought to be our answer. Because it's pretty clear there's no other route, no? If you want to minimize, you want to use these, as many times as possible, the shortcuts essentially. And yeah, because you have to go to the post office and the bank. The only way that would then make sense is the way we have used it. So that's your answer. Surely that's your answer. 3200. Let's get rid of all these drawings, if that is what we can call them. Also this. Okay, let's look at the next question. The next question says, I think it's 300. Yeah. This post office. The next question says, question 2, one person enters the gated area, decides to walk as much as possible before leaving the area without walking along any path more than once, and always walking next to one of the lakes. Always walking next to one of the lakes. The person may cross a point multiple times. Good to know. How much distance will he walk inside the gated area? If you want to, cover all the, areas around the lake, you can basically do something like this: C to D, D to E, E to F, F to K, K to L, L to M, right? L to M, M to N to K, this, and back here. You're not walking on any path twice. Your route is something like this. This. You'll pass this point twice, which is okay, which is allowed. Here, and boom, here. So you basically have to calculate the perimeter of the lakes. That's it. That's what you need to do. Just calculate the perimeter of the lakes, and you'll find your answer. So the perimeter of your lakes is going to be, this one, the perimeter would be, this is 400, this is 300, 7. So perimeter is going to be 1400. This is also 4 and 3. So, this is going to be 1400 as well. Perimeter of this lake. And then this is 200 and 300. So perimeter is going to be 1000. This is 2800 plus 1000 here, 3800. That's your answer. Question number 2 is option 4. I hope this is clear. Let's move on to the next question. Okay, we don't need all of this. Save space. Question 3 says, one resident walks within a gated area starting from A, okay, and returning to it without going through any point other than A more than once. Just A twice. Can't even go through another point once, right? Just once. More than once. So what is the maximum distance she can walk in this way? You want to walk within the gated area starting from A, ending at A. Now, look, you'll have to decide, right? So, what do we do? Do we do something like this, and something like this, or maybe skipping something in the middle, or are we going to go like this, something like this, right? You'll have to choose, right? What if you're trying to maximize maximum distance? If you're trying to maximize the distance, what you should try to do here is you should try to make sure that you walk along the paths of higher length, right? The greater distances, the 400s. If you have to skip a 200, it's okay. Try to avoid skipping a 300 for a 200. Yeah. So I think a good route would be AB. I'm going to draw that here. AB, BG, GF, FC, and I think a little bit of hit and trial here will help. CD, DE. You can't even pass a point twice, remember. So you can't go from E to F. You have to go from E to L. And it would probably make sense to go then all the way down, right? L to M, M to N, N to K. K ought to be here. I'm sorry. K ought to be here. Here is nothing. and then K to J, J to O, O to P, and super back to A. I think forming an H, right? That ought to be your best bet. So that'll be A B 150, and then BG. Should I do it here? 150 plus this is 400. BGGF is 300. And then this is 400 again. See if you add this up, it helps you. फटाफट add करना, it makes sense. But yeah, I'm just going to do these bits here. This 300, and then straight down is 1000. This is straight away a total of 1000. Could we have done something else here? No, I don't think so. No, I think this is the highest. Yeah. Then 1000 from here to here. Then it's 300. This 400. This is 300 again. This is 400 again. This is 150, and then again, boom, straight back 1000. So if you just add up, right, 150 into 2 is 300. 300, 306, 639, 9 for 13, 13 for 17, 17 threes, 20, 2300, 27, 27 and 4, 27 and 4 is 3100, 3100 and 1000, 4100, 4100, 1000, 5100 meters. That ought to be your highest distance, the highest distance you can walk. I hope this is clear. The last question of this set says, visitors coming in from morning walks are allowed to enter as long as they do not pass by any of the residences. Okay. You cannot pass by any of the residences. So you can't walk along the path that has residences. You can't even walk on, or you can't even pass the points A, H, LM. Remember, these were our 4 points that are residences. We can't use them. Fair. So you're entering from C. You want to pass only C more than once. You can't even pass a point more than that. Great. So you can go right or left. I'm not sure if that is going to make a lot of difference. I see more space on the left, so I'm going to take the left turn first. C is here. Can't pass A, so you'll probably go from C to B. Then B to G. Of course, you can't pass through H, so that's a problem. Yeah, and since you're trying to maximize, you'll not take the shortcut. Forget about the shortcut now. Shortcut is done, right? You want to cover more points until unless the shortcut helps you cover an extra point. If that happens, that's a different case. I don't think that is going to happen. Because I think you can go then all the way down to J and then to I. Yeah. And then you can go from I to P, P to O. Again, is there a benefit of taking that that shortcut? No. You'll basically end up missing N because you can't go to M or L. You can't go to point M or L. So from O, you should go to N. I'm sorry. And then go to K. You can't go back to J. You can't go to L either. So you have very little choice, to be honest. You'll have to go to F. And from F, of course, you can't take a left turn now. E, D, C, back. So that ought to be the best part. You could obviously have retraced, right? Instead of going towards the left, you could have gone to the right and then done something like this. So that's what you have. That's what you have. Because see, these paths are ruled out. No, KL is ruled out, NM is ruled out. So you better cover KN. That's the only thing you can do. And even EL is ruled out. So FK, we're covering FK. We're covering FE here. This path is ruled out. This was ruled out. This was ruled out. So yeah. So we've actually covered everything, pretty much everything we could. So that ought to be our answer. That will come out to be, it's not that difficult at all. CB is 300. Then B all the way up to J is 6. This is 6. JI is 150. IP is 400. This is another 150, of course. PO and then ON is 300. NK and then KF is 600. This is 600. This is still here. FE is of course 3, and DE is 4. CD is 3. Just add this up, you'll get your answer. Right? 369, 900, 903, 150 twice. So 9 and 3 is 12, 12 and 4 is 16, 16, 3, 16, 3, 19, 19, 6, 25, 25, and this is 25, and this is 1,000, right? I hope you've got it right. Nine, 3, 12, 16, 16, 3, 19, 6, 25, 25, and this is 1,000. Yeah, 3,500. 3,500 should be our answer. Let's move on to the next set. I think this had just 4 questions. Okay, let's look at question 5 to 8. Question 5 to 8 talks about an online e-commerce firm that receives daily integer product ratings from 1 to 5 by buyers. The daily average is the average of the ratings given on that day. Fair enough. That's the daily average. And then there's a cumulative average, the average of all ratings given on or before that day, which means cumulative ratings for 3.1 at the end of day 2 would include all possible ratings for day 1 and day 2. And distribution of ratings are given here. So day 2 you can calculate easily. Yeah, day 2 you can calculate easily. We'll only do this if the questions demand. So let's have a look at the questions first. And then some information about ratings on day 3 is given. 100 buyers were gave product ratings on day 3. The modes were 4 and 5. Number of buyers are non-zero multiples of 10, so which at least 10, right? And multiples of 10. And the same number of buyers gave product ratings of 1 and 2. And then this is talking about day 3. Something is known about day 3, which is rating of 3, which is double of 1 and 2. Fair. What are the questions? The questions are, how many buyers gave ratings on day 1? Okay. What is the median of all ratings given on day 3? Fair. Daily average rating of day 3. Okay. Which of the following is true about the cumulative average rating of day 2 and day 3? Cumulative average. Okay, cumulative average. Cumulative average were the all the other days. Okay, fair. So we'll have to be careful. We basically need the average rating of day 3 and even the number of buyers. Yeah, so you have to work this out using the data given. I think the data for day 2 is obviously going to be key. Let's first figure out data for day 2. 10 buyers have given rating of 5 each. That's a net 50 points. 20 have given 4 each. That's net 80. 10 have given 3, so that's 30. 10 have given 2, 20. 5 have given 1, 5. Aha. 5 buyers, 1. Okay, this surprisingly ends in 5. Okay, so this is, what is this? 130, 130 and 50 is, 130 and 50 is 180. 185. I hope you've done this right? 10 into 5, 50. 4 and 20, 80. 3 into 5. Aha, this is not 3 into 10. So the reason I was surprised was because, I could see this, we'll end up getting a decimal. So, yeah, we made a mistake here. It's 3 rating into 5 by 15. So it's 20, 20, 40, 40, 120, 170. Our net sum of all ratings is 170. How many people do we have? 10 plus 20, 30. 30 plus 5, 35. 35 plus 5, 40. 40 and 10, 50. Our number of people is 50. So day 2's average is simple, right? Average value of day 2, let me call that A2, is 170 by 50, which is 3.4. Good. And we have the net sum. How will that help us now? How will that help us? Look, should we write it at the next page where we solve our questions? I think we can. Look, day 1, I just know that here, yeah. Let's make a small final table, right? I think that's going to help. Day 1, day 2, day 3, number of people that rate, average rating, daily ratings, uh, daily average, and then cumulative average. In fact, maybe we should have a number of ratings into daily average is the sum of all ratings, and then we can I think we can do cumulative average, so that'll help. So if my daily average for day 1 is 3, if my number here were to be n, the total sum would be 3n. My daily average for 2 is 3.4. Another number is 50. You just calculate all that. Sum is 340. Cumulative average after day 2 is 3.1. Is not what the question says. Yeah. So what is cumulative average? Cumulative average for day 3 after day 2 is going to be. I'll use this space for solving. The 3.1 rating is the total sum of all ratings on day 1 and day 2. Day 2 sum of all ratings is 170. Day 1 sum of all ratings is 3n, 3 into number of people who are giving ratings, upon the total number of respondents. That is 50 on day 2, yeah, and n on day 1. Just solve this. How difficult is this? Not difficult at all. 3.1 into 50 is 155, and 155 plus 3.1n, it's easy to solve. 170 plus 3n. So 3n, 3.1 minus 3n is 0.1, and that comes out to be 15, and therefore n is going to be just multiplied by 10, 150. Number of people who have rated someone on day 1 is 150. So that helps you, that will help you, and is 150, and the sum will be 450. That is also one of our questions, so that's done. 150, 450. Cumulative average, of course, was 3. Is not no big deal. And if you want to solve all the questions, of course, then we do need, in fact, except the first question, I mean, we would need to, solve for day 3 as well. So let's get of all this data because it's not required. What does the day 3 information tell us? That 100 buyers gave product ratings on day 3. Just 100. The modes were 4 and 5, and the number of buyers giving product ratings are non-zero multiples of 10, right? So rating 1, 2, 3, 4, 5. These are the modes, right? The most frequent. And both 4 and 5 are the mode. It means the number of ratings given, rating 4 and 5 would be equal and greater than 1, 2, and 3. And these are all non-zero multiples of 10. A number of buyers given product rating of 1 and 2, that number is half of the number of buyers who gave a rating of 3. 1 and 2 is half of 3. 3 is double. It multiple of 10. What does that mean? I mean, this would have to be just 100 in total, right? Total is 100. So at least 10 each. 10 the minimum hai. So this would be 20. This 20, 20, 40, and 40 equally divided. There are the 60 divided would be 30, 30. Does this work out? It does work out because 30 is the mode, more than 10 and 20, and everything else we've met, right? Can ratings for 1 and 2, rating 1 and 2 be 20 each? Multiples of 10 only, non-zero multiples. So 20 each would mean this is 40. Now this doesn't work out because 40, 40, 80 would mean ये 10, 10 आ रहा है. 10 is okay, but it ceases to be the mode, right? It ceases to be the most frequent. So ये नहीं हो सकता. 30 तो कोई chance ही नहीं है because 30, 30, 60, this is already greater than 100. Total number of responses. So the only possibility is your 100 respondents work like this. 10, 10, 20, 30, 30. Goodbye. That's it. So, yeah. And can you calculate average and all that? Absolutely, yes. Your total number of respondents is, okay, we'll do that. Let's just calculate average first. Your total sum of ratings will be 1 into 10, 10, plus 2 into 10, 20, plus 3 into 20, 60, 4 into 30 plus 5 into 30, that's 9 into 30, 270. So that is how much? 30 to 70, 360. is 360 by 100. 360 by 100 is 3.6. That's the net rating, daily average rating for day 3. 3.6, 100 respondents, 360 net sum. Cumulative average, do we need cumulative average? Question number 4, we need cumulative average. Now, what will cumulative average be? At the end of day 3 is very simple. The total sum, 450, 170. We had 3.1, but yeah, it's just 450, 170 is 620. 620 and 360 is 980. How many respondents? 150, 50, 200. 200, 100, 300. Yeah. So this is a irritating whole number, right? This is an irritating whole number. It's not even 3.3. I don't think we've got it wrong. I'm surprised it's not divisible by 3. Let me check once. This was 170 only, right? Yeah. Yeah, this is correct. Yeah, this is all correct. Yeah. So, I mean, if it comes out to be such a horrible number, we can't help it. This is going to be 98 by 30. 99 by 30 would have been 3.3. This is 3.267. I guess 26 bar actually. So yeah, that's what it is. Fair enough. Yeah, net cumulative average 3.26 bar. Fair. We can also just leave it as 98 by 30. Now, how many buyers gave ratings on day 1? 150. We already know. Done. Daily average rating. Daily average, not cumulative. Daily average rating on day 3, easy 3.6. Median of all ratings given on day 3. Median is the middle value. Median of all ratings would be the, average of the 49 and the 50th. They'll both be 4, no? Because these are your first 40 respondents. And the 40th, from the 41st to the 70th respondent, they've all given 4 ratings. So, I mean, the 49th or the 50th and the 51st would both have given 4. So that's 4. Median of ratings, 4. And then finally, what is true about the cumulative average rating of day 2 and day 3? It changed from 3.1 to 3.26. See, if you don't want too much hassle, let's just change it to 3.27. 3.1 to 3.27. What is the change, or what is the percentage change? Because it talks about the percentage change. It decreased. This is not correct. The cumulative average decrease is not correct. The cumulative average of day 3 increased by more than 8%. Okay, we'll have to check the percentage. This is, let's say this is a change of 0.16 upon 3.1 into 100. So that's 16 upon 3.1. 16 by 3.1 is very, very close to 5, right? Close to 5%. Yeah, more than 5%, but not more than 8%. So the cumulative average of day 3 increased by a percentage between 5 and 8. Absolutely right. Because it's 5 point something. It's 5 point something, right? 3.1 into 5 is 15.5. So it's more than 5%. Less than 5 is the wrong answer. Option 3 is absolutely right. I hope this set is clear. It's a decent set. I don't think it's either very long or very difficult. A little bit of calculation, a little bit of work, of course. You can't run away from that. Let's look at question number 9 to 12. Okay, guys. Let's look at question number 9 to 12. Okay, what does 9 to 12 say? 9 to 12 says there are 2 plots. Okay. And 2 plots, they have PAT, profit after taxes, and then there is ES, employee strength, and the question also talks about the percentage of the firm's PAT, so percentage value that is spent on research and development, right? Obviously, it's a percentage. So, its final application will happen on the PAT, as in if you want the final value. And the PRD values are proportional to the areas around the points representing each firm. Areas around the points. So, areas would mean these circles, right? So, the area of a circle is, of course, pi r square. So, in terms of percentage, this would be proportional to, r square. So, if you look at this, for example, this is a radius of 1.5 units. See, if I take this to be 1 unit, consistent value of 200, interval of 200, and it's 200 here as well. So taking this as 1 unit, difference of 200, the interval of 200, this would be about 1.5. This is about 300. So we're not going to take this as 300, or maybe we would have to if we need the value. Let's look at the questions once. But in terms of units, this is 1.5 unit. This is about 1 unit. This is about half a unit. This is about 1.5. This is about 1, right? Because the total is 2. So yeah, this is about 1 unit. And so on and so forth, right? Both sides. This is true for both sides. So yeah, let's look at the questions. Question 1 says, assume that the annual growth rate in PAT over the previous year remain constant over the years for each of the 6 firms, right? So a consistent rate of growth. Which firm had the highest annual growth rate? Look, if I'm looking at annual growth rate, yearly growth rate, and because you're looking at all firms from 2019 to 2023, fixed period of time, we can just calculate the total percentage change. That will also work. The firm from these 4 options, which has the highest percentage change, will have the highest annual growth rate as well, because we're talking about a fixed period of time. So, let's look at the options. Firm B's PAT changed from 2,800 to, okay, I think this is B. This is B, right? Yeah. Because there is small, I think this has to be, yeah, this is B, this is D. I hope it's visible on screen, right? This is very fine margins in terms of the legibility, but yeah, this is B. So B has changed from a 2,800 PAT, right, here, to a 3,800 PAT. So the percentage change is, of course, the change in value, which is 1,000 crores or 1,000 units, whatever it is, upon 2,800 into 100. So that comes out to be 1,000 by 28. 1,000 by 25 is 40. This is going to be 30 point something. So firm B is 30 point something. What is firm C? Firm A, let's check. Firm C changes from 2,400 to 3,000. 2,400, 3,600 by 2,400, right? 600 by 2,400 is 1 by 4, 25%. Firm C is much less than B. A has gone from 3,000 to, this is 3,900, right? Right in the middle. 3,000 to 3,900 is 30% change, exactly 30%. This is 30 point something. It's not 30 point as in 30s. B is in 30s, much more than A, which is exactly 30. Right? 30 to 3,900. I hope I don't have to do this for every single company, because 3,000, 3,900, that's a change of 900 crores, 900 points upon initial value into 100. So this is exactly 30. Firm E has gone from 2,400 to, this is 3,500. Now this is nearly 50%, right? 2,400 to 3,600 is exactly 50%. This value is exactly 50%, slightly less. Even if I take 35 here, it's going to be much more than 40%. So surely E is the answer. Your answer is, without a shadow of doubt, E. I hope this is clear. Let us move on to the next question. Must also create a bit more space here. Okay, next. Question 2 says the ratio of the amount of money spent on, now we're talking about the amount of money, right? We're not talking about the percentage, because it's talking about R&D. So the amount of money spent by firm C in 19 to 2023, ratio. Now in 2019, C has spent from 2400, 1.5, right? 1.5, the radius is 1.5. So in terms of the value, it will be pi r square. I'm going to ignore pi because you're looking at the ratio. Pi will get cancelled out. Right? So pi r square as a percentage, ignore pi. R square is 1.5 square into, and I mean, we can have 100, but again, it's a ratio, it will cancel out. Let's assume this was 1.5 square percent. So upon 100 into 2400 crores is to C's values in 2023 is, this is 1 unit. 1 unit, right? So 1 square upon 100 into 3000. So, this is 3 by 2 whole square. 3 by 2 whole square is 9 by 4. 2400, 3000 is 600 into 4, 600 into 5. 9 by 4 into 4 is to 5. That's 9 is to 5. Straightforward. I hope this is clear. Straightforward question. Yeah. Question number 3. Which among the firms A, C, E, and F have the maximum PAT per employee? PAT per employee in 2023. PAT per employee for A. PAT per employee for A is going to be straightforward, right? 3900 by 1300. 3900 by 13 is 3 crores. Firm E. Firm E is 3500 by 14. 3500 by 14 is definitely less than 3, right? This is 3500 by 1400 employees. 1400 into 3 is, 4200. We're looking at the maximum value. So E can't be the maximum value. This is less than 3. There's no doubt. Don't waste time finding the exact value. It's not required. For F, this is 3200 by 1000. 3200 by 1000 is 3.2. For firm C, it is 3000 upon 800, right? 800 employees. 3000 by 800 is almost 4. 3000 by 800 is actually 3.75 because it's 30 by 8. 30 by 8 is exactly 3.75. Surely your answer is firm C. This so far is turning out to be the easiest question, right? I mean, the shortest also. Option 4 says which among the firms C, D, E, and F have the least amount of R&D spending? Amount of R&D spending per employee. Now this involves everything clearly, right? Because we have to think in terms of actual R&D spending, not this percentage, and divide that by the number of employees as well. So let's look at this figure for D. And again, I'm going to ignore constant, right? Pi is a constant. It's going to get multiplied for each of the 4 firms. So ignore it. So for D, this figure is going to be 2023. This is going to be this circle has a radius of 1. So 1 square upon 100, 1%, right? 1 square is 1% of the PAT, which is 2400. Oops. Upon the number of employees per employee. So number of employees is 800. Look, I will ignore the 100 because again, this 100 is going to come up in every case. It's just part of the constant. Can't ignore this. So I'm just going to take the percentages, which are the square of the radii, into PAT upon employee strength. For D, that figure comes out to be 3. What the units are, we don't know. We don't care. We just have to compare the highest to the lowest. We're talking about the least here. D has a value of 3. Let's see what the others throw up. What is C? C is radius of 1. C has a radius of 1. So 1 square into 3000 upon 800. 1 square is obviously 1 into 3000. We've just done this calculation upon 800. So this figure is going to be the same, right? Just done it 3.75. Definitely not the least. A waste of time in terms of, surely it's not the answer. E, what about E? E is here. E is 3500. And what is this? 1, 2, 3, right? 1.5, right? 1.5 is your percentage. 1.5 square. 3 by 2 whole square. 9 by 4 into PAT 3500. Employee strength 1400. So 35 is 7 into 5. 14 is 7 into 2. This is 45 by 8. 45 by 8. 45 by 8 is more than 5. Right? Greater than 5. There's no way this is the answer. Firm F, finally, last option. Radius is 1. So 1 square, which is 1, into 3200 upon 1000. So, I'm unable to write. Never mind. This, is 3.2. So, clearly this is not your answer either. Your answer is firm D because it's 3. Relatively straightforward question. I hope you got it. Let's move on to the next set, question 13 to 17. I'm just going to make some changes to my writing tab. Okay, great. Next question says, the next question, I remember this doing, remember this in the exam because I felt this was one of the 2 sets that you could quickly have solved fully, and then maybe picked up a few questions here and there from the others. And this has 8 gymnastic players, coached by 3 people, fair, and Yuki trains only even number of players. The people the coaches train is given, or the people they don't train is given. There are 7 players, and some other detail is given. If you read all this, you'll realize a good simple, because there are not too many variables. A good simple table to make would be player numbers 1, 2, 3, 4, 5, 6, 7, 8. Super. Actually, we have a lot of space on the right. We can use it. And then, of course, the coach names, and then the ratings. A simple, neat table to make here. And let's start filling this. Every coach is trained at least 2 players. Good. Yuki trained only even numbered players. Okay. Everyone is coached at least 2. So X, Y, Z all have trained at least 2. Super. Now we have 8 players. Everyone is training at least 2. I don't think there are too many cases, and I think if we combine that with point number 1, we'll probably end up with even lesser cases. So we'll look at what we can do here. Yuki trained only even numbered players. So Yuki may not have trained 4 people, so I can't hang around and say just focus on 2, 4, 6, 8. What I'm going to do is actively say that Yuki did not train odd number players. So Yuki did not train player number 1, nor player number 3, not player number 5, not player number 7, because that is definite information, right? Even if it's a negative piece of information, it's a definite information, use it, helps you. Zara trained only odd numbered players, so no even numbered players. So player number 2 was not trained by Z, neither was player number 4, nor was player number 6, nor was player number 8. Super, good news. Next. The coach's value to player gives integer ratings on a scale of 1 to 7. 8 players, 7 ratings, good. 1 being the lowest, 7 being the highest, good. The question says, Zena trained more players than Yuki. Good to know. X has trained more players than Yuki. Okay. Now, we can actually start from here, right? If Y has trained 2, X has trained more than 2, surely, because Y would have trained at least 2. We can probably make cases. Yeah. Would that be prudent? Let's see. If Y has trained 2, Z would have trained, X would have trained 3. That's 5. Then Z would have trained 3. That's one possibility. Obviously, it is also possible that Y trained 2, X trained 4, 6, and Z would have trained 2, 8 players in total. Yeah, with Y as 2, X can either be 3 or X can be 4. Z automatically comes out. X can't be 5 now because 2 plus 5 is 7, and then Z would only be left with 1 player, so that doesn't work out. Could Y have trained 3 players? No, because X has to be more, at least 4, and then Z would end up having just 1 player to train. That violates the given condition. So we actually, in terms of number of players, we have only 2 possibilities. I think it is useful to know that these 2, the ones given here. And that means we move ahead. we move ahead and look at what the question was trying to say. Player 1 and player 4 were trained by the same coach. Now, player 1 is not trained by Y, player 4 is not trained by Z. If they have to be trained by the same coach, that coach has to be X, surely. Very useful piece of information. While the coaches who trained player 2, 3, and 5 were all different. 2, 3, and 5, three players, three different coaches, X, Y, Z. Now, 3 and 5 have not been coached by Y. 3 and 5 have not been coached by Y. So, 2, 3, 5, if I need Y somewhere, it has to be player number 2. And then 3 and 5 will be coached by X and Z. One will be coached by X, the other will be coached by Z. So, yeah, fair enough. Next, player 5 and 7 were trained by the same coach. Good to know. Right? Player 5 and 7, same coach. And they got the same rating. Aha, good to know. So if 5 has a rating of n, then 7 also has a rating of n. Same rating. All other players have got a unique rating. Fair enough, right? 7 players, 8 players, 7 ratings. So someone has to get, 2 people have to get the same rating. Everyone else has a unique rating. So all ratings from 1 to 7 will feature. That is good to know. The average of the ratings of all players was 4. Average. Now I have 8 players, right? I have 8 players. Average is 4. It means sum of ratings is 32. That's my sum of ratings. How is that possible? How is the sum of 32 possible? If my sum is 32 and everyone has each of these, I mean, all the players have at least, 1, 2, 3, 4, 5, 6, 7. I have 7 unique ratings. And one rating which matches one of these. Now 1 to 7, I can immediately add up, right? I can use a formula for sum of first and natural numbers, or AP, right? First plus last term upon 2, 1 plus 7, 8 upon 2, 4 into 7. This is 20. This sum is 28. So the player with the same rating would have been 4. There are 2 players with a rating of 4, right? 7 unique and 4 repeats, which is very interesting. So the 2 players that have the same rating, what would they have? Would have a rating of 4 each, because there is no other case of repeat ratings. I hope you got it. 32 is my total sum. 7 ratings, 1 to 7 unique, everyone gets it. 24, 8 is a sum, and then that means 32 minus 28, 4 is the other repeat rating, and those are for players 5 and 7. So, and they've been coached by the same player. Lovely, good to know. So that'll be 4. So we don't know the coach's name yet, but I think we'll figure that out. The average of the ratings of all players was 4. Good, that helps. Player 2 got the highest rating. Now this becomes simple. Unique ratings, player 2 highest is 7. The average of the rating of the player trained by Yuki was twice of that of the players trained by Zena. Okay. If Zena's average rating is A, Yuki's is 2A. And 2 more. Yuki's rating is 2 more than that of the players trained by Zara. So, Zara would be 2A minus 2, 2 less than Yuki. Now, I know the sum of ratings, right? I know the averages for X, Y, Z. I don't know the numbers yet, but I have 2 cases for numbers. Can't I check which one will give me 32 as a total sum? Just check. So what is case number 1? 3, 2, 3. Could these be the possibilities? Just check that if I have the average ratings for A, Y, and Z, and these are the number of players they've coached, then the total sum should come out to be 32. So yeah, this is 3A plus 6, 3A plus 4A, I'm sorry, 7A. 7A plus 6, that's 13A. We have space for calculations. 13A, and we had a minus 6. 13A minus 6 is 32. So that will give me A as 38 by 13. Now 38 by 13 is not A is not a natural number, right? Average ratings can't be decimals. Definitely not 38 by 13. So so surely, right? I mean, this is, you'll have to rule this out. You'll have to rule out this case, which is good for us because it gives us space. This is gone, and thus we have these number of players. X definitely has 4 players under him or her, Y to Z2. And we'll have to check what A comes out to be. This is 4A plus 4A, 8. 8 and 2A into 2, 4, 4, 4, 12A. So 12A. There is such a lag. Yeah. 12A minus 4 is 32. So 12 will be 36, right? A is 3. So A is 3, that's good to know. So, X, Y, and Z, these are the number of players. These guys are training. And their average ratings. X will be, because A comes out to be 3. X rating is 3. Y's rating is 6. And Z's rating is 2 less than 6, so 4. Great. Now, look, there are 2 players coached by the same player and Z. That has to be Z, right? If I have an average of 4 with 2 players, the only possibility is this. And why do I say that? Y is an average rating of 6. Y is training one player with with a rating of 7. So the other player would have a rating of 5. 2 players with average 6 means 12 is the sum. So who has a rating of 5? We'll have to figure that out. And I think we have one line left. Player 4's rating was double of player's 8 and less than player 5. Player 5 is a rating of 4. 4 is less than that and still double of something, so even. So player 4 would have 2 as a rating. 8 has less, so 1. There's no other possibility here. And Y needs to coach 2 players. Y needs to coach 2 players. Y can't coach player number 1 or player number 3 or player number 5. So the only player left for Y to coach is player number 6. And the rating of that player is going to be 5 to get a sum of 12, to get an average of 6. Y we have done. Super. Now, Z, this must be the only possibility, right? Z with an average of 4. Because what other case would you have? 7 and 5 are taken. 6 and 8, 6 and 8 doesn't make sense. 6 and 2, right? If I want an average of 4 from 2 players, I want a sum of 8. How do I get a sum of 8? 7 plus 1, that is not possible. 7 is coached by, player with rating 7 is coached by Y. 6 plus 2, 2 is coached by X, not Z. 3 plus 5, 5, someone with the rating of 5 is coached by Y. So the only way to get a rating of 4, average rating of 4, is if these two players coached by the same person, that coaches Z. I hope this is clear, because once you get it, you basically get everything. You have the 2 players with Z, everyone else has been coached by X. So, X, X, and X here. 1, 2. Now we won't be able to figure out who is 3 and who is 5. Those are the only 2 rating types. 1, 2 we figured out, 3 not figured out, 4 we figured out, 5, 7 figured out. So this would be 3 or 6. And of course, the other player would be 6 or 3. That's it. So let's look at the questions now. What best can be concluded about the number of players coached by Zara? Zara, of course, 2 players. I mean, this is straightforward. Question number 2. What is the rating of player 7? Player 7's rating is 4. Right? Player 6 rating of player 6 is 5. How many players can the ratings be determined with certainty? Out of 8 players, 6 players we can determine with certainty. So the answers here are, let me mark them here once. The answers here are exactly 2 for question 1. Rating of player 6 of player 7 was 4. Rating of player 6 was 5. And 6 players, their ratings can be marked with certainty. 4, 5, 6. Very nice. Let's move ahead, guys. Let's move ahead and solve the last set. Let me just check if everything is working. Okay, everything is working. Good. Last set. What does the last set say? The last set says that there are 10 numbers placed in 10 slots. And numbers in a row appear in increasing order from left to right. You can pause the video and read it if you want, if not solved this yet. So numbers appear increasing order from left to right, fair, and then decreasing order from top to bottom. Super. Now, that's very interesting. Where will your smaller numbers lie if I want to organize? In terms of the columns on the left, right? On the left, and in terms of rows on the left. In terms of columns, the smaller numbers will lie at the bottom, and the higher numbers will lie on the rightmost, as well as the topmost. So where can 10 go? 10 has only one place then, right? Because 10 can't go here, right? I can't put 10 here because then I need a higher number to the right. That's not possible. I can't put 10 here because I would need a higher number here. That's not possible. The only place possible for 10 is row 1, column 4. Done. That's the best part about this question. Then the question says 1 is placed either in the same row or the same column as 10. Same row or same column. If it's in the same column or same row, then 1 would be here. If it's in the same column, then 1 would be here. So there are actually just 2 possibilities, and I think both may be worth exploring. We may need to make cases. Let's see. Let's see if we need to make cases. If we don't, that'd be good. If we need to, we have to. So right, 10 is fixed. Great. This has been done. Neither 2 nor 3 can be placed in the same row or same column as 10. So same row, same column is done. Where can 2 and 3 come? Only here. No other possibility. This is the only place for 2 and 3. The same way, even in the second case. Only place for 2 and 3 is here. Right. So 3 out of these 3 cells, 2 have to be occupied by 2 and 3. Neither 7 nor 8 can be placed in the same row or same column as 9. Now, 9 is a very big number. Where can 9 go now? Can 9 be here? No. Because if this is decreasing order, then 10, you need a number higher than 9 for 9 to follow, if 9 were to be here. Or 9 here. 9 can't be here because then you need a higher number here. Right? As you go down a column, you need decreasing order. So the only possibilities for 9 are either here or here. So there's just 2 possibilities, right? 9 can either be here or be here. Maybe you'll have to check both, worth exploring. And then 4 and 6 have to be placed in the same row. This is also very useful as an organizing principle. 4 and 6 in the same row. Now, should we use this first, 4 and 6? Now, where do I put 4 and 6? Here is possible. Here is not possible. 4 and 6 will never be in these 2 positions because 2 out of these 3 have to be occupied by 2 and 3. Right? These 3 positions, 2 are used, or 2 will be used. So I can't use 2 more for 4 and 6. It's not possible. But 4 and 6 can be here or they can be here. Let's just check, one by one. I'm just, doing a hit and trial based on using this as one of the organizing principles. So if I put 4 and 6 here, where does 9 go? 9 goes here then. Great. What do I do with 7 and 8? Now I have a problem because 7 and 8 can't come in here in this line. Yeah, can't come in here. 7 and 8 can't come in here. I'm only left with one place for 7 and 8. That's not possible. Two numbers need two places. So that basically tells me that 4 and 6 cannot appear here. Goodbye. What about the others? What about the other positions? Of course, I mean, these are a possibility as well. Let's see, 4 and 6 can appear here. If I put 4 and 6 here, 2 and 3, 2 and 3 will use up these two places. Good for us. 9 now. Where does 9 belong? Therefore, 9 has to belong here. Now, 7 and 8. These two have been used by 2 and 3 or will be used. 7 and 8, the only places are here. Problem. 10, 6, right? 8, 7 is not decreasing order. So it's not possible. So if I use 4 and 6 in the second row, it doesn't work. So for this arrangement where 1 is at the leftmost position, same row as 10, there is only one possibility for 4 and 6, which is this. Let's hope this works because it's the last possibility. If this doesn't work, you've checked 4 and 6 here, you've checked 4 and 6 here, doesn't work here, it means we'll have to discard the idea that 1 belongs here. And therefore, we'll have to focus on the second case. Good. 4 and 6 is here. Immediate problem. Where do I put 2 and 3? I'll have to put 2 and 3 here because left to right is increasing order. But there is a problem. Decreasing order has been the constraint, that condition has been violated because 4 is higher than 3, not lower. So 4 and 6 can't appear here. Obviously, 4 and 6 can't appear here. Goodbye. So that basically means this case is invalid, useless, and therefore deserves to be left out of consideration. And therefore 10 is here. 1 can't come in here in the same row. 1 has to appear here. No other possibility. Now I can still use 9 as an organizing principle, or we can continue to use 4 and 6. Let me. I think 2, 3 possibilities. Maybe do well to do this and then discard it rather than erasing, which takes time. Okay, 10 and 1 is here. Where will 4 and 6 come in? And of course, we know 2 out of these are booked for 2 and 3. 2 out of these 3 cells. I think we would not be a bad idea to fix 9 first. Or not. Let's just go ahead. If 4 and 6 are here on the left side, 4, 6, increasing order, so same row. 2 obviously can't come in here because then there's no smaller number. Okay, 4, 6. Where will 9 go? Let's see if 9 can be here. If I can put 9 here. 4, 6, 9, good. I'm left with 8 and 7 then. 8, 7. Okay. 1 is done. 2, 3, 4 is here. 5. 5 would surely have to be here. 5 can't be here because then you need a bigger number. You're left with 2, 3, 5 now. So 5 will have to come in here. And either 2 or 3 here, and either 3 or 2 here. This actually does work perfectly, right? 6, 2 or 3 decreasing order, 5, 9, 5, 3, 2, 10, 8, 7, 1. Everything is in order. This definitely works out. Good. Hit and try, right? I wouldn't say we got lucky. We've just been trying so much. So this works out. And we got this case by first fixing 4 and 6 here and then trying 9 here. Can we just try this again? 4, 6 here, but not 9, not here, but here instead. Can I put 9 here? No, the problem with putting 9 here is, where do I put 7 and 8 now? Right? Can't be put here, can't be put here. And I can't really put 7 or 8 here. So, if I put 7 or 8, one empty place, I'll have to put 8 or 7 here. And what do I do with this number then? Right? Let's assume this is 8. Let's assume this is 7. then this is not decreasing order, because 8 has to be followed by a smaller number, and further decreasing 7 doesn't make sense. Right? A smaller number here could have been 9 has been taken. Sorry, 9 is not lesser. 6 has been taken. If I put a 5 here, let's say, then 8, 5, 7 is not decreasing order. So the moment I put 9 here, having put 4 and 6 here, I cannot put 9 here. So clearly the case above works and the case below doesn't work. This is a working case. We'll park this and we'll see if other cases work out. Using 4 and 6. Using 4 and 6. I think this would work out much better on pen and paper. But that's it. How it is. This is 4 and 6. Good. Of course, now if I'm putting 4 and 6 here, 9 would have to come in here. Good. Again, where do I put 7 and 8? I cannot put 7 and 8 anywhere because the only place left is here. And then this is not decreasing order. Because 6 is here, I can't put 7 here. Yeah, so this doesn't work out. Putting 4 and 6 doesn't work out. I have to put 9 here if I want to arrange the order. And then 7 and 8 have no place. So sorry, this doesn't work out. So what are we left with? We are left with the second row for 4 and 6. The second row. First row is done. Now, we already know that out of these 3 cells, 2 will be occupied by 2 and 3. Can't be in the same row or column as 10. So 4 and 6 can't occupy these 2 places, but 4 and 6 may possibly occupy these 2. And then, of course, 9 would have to come in here. Where do I fit 8 and 7? Right? These positions I can't, not in the same row as 9. This position I can't. So 8 and 7 are fixed for these 2. That doesn't work out because these 2 I've already taken. Right? Once I fix 4, these 2 have to be taken by 2 or 3. So 7 and 8 are left with just one cell for themselves, and that is wrong. That doesn't work out. So this is definitely not valid. So 4 and 6 do not belong to the second row. Do 4 and 6 belong to the third row? Let's check. If 4 and 6 are here, if 4 and 6 are here, problem. Where do I put 2 and 3? 2 and 3 I would then have to put here, right? Away from 10 in the same row column. And now this violates the decreasing order. 3 is smaller than 4, not bigger. And thus I can't even put 4 and 6 in the third row. Can't put in the second row. Only possibility is 4 and 6 here. So that actually gives us the only possible case. 4, 6, 9, 10, 5, 8, 7 here. Either a 2 or a 3 here, and either a 3 or a 2 here. All the data works out. That's it. That is your answer. You can run through the the points once if you want, but I'm quite sure that's it. What is the row number that's the least sum of numbers placed in that row? Good to know, because the least sum is row 4, because row 4 has just one number, 1, the smallest number, so it has to have the least sum. Done. Which of the following statements must be true? 10 is placed in a slot in row 1, of course. And 4 is placed in a slot in row 4. Absolutely yes. Both are true. Both statement 1 and 2 are true. Which of the following statements must be true? 2 is placed in column 2. 3 is placed in column 3. Both are incorrect, because 2 and 3 we have not been able to place their row and column. Right? They have 2 possibilities. So neither 1 nor 2. Right? We check here. 2 can be in column 2. 2 can be in column 3 as well. And the same way, 3 can be in column 3 and 3 can be in column 2. So nothing you can do about it. Both are false. How many slots on the grid cannot be determined with certainty? 2. The places for 3 and 2. They can't be determined with certainty. All the others can. So that's it. And what is the sum of numbers placed in column 4? Column 4 sum of numbers is 10 plus 8 plus 7 plus 1. 18, 25, 26, right? So that's your answer. That's it. This is the sum of numbers in column 4. It's 26. That's it. And that also finishes our our presentation for CAT 2024 slot to DILR. I hope you got it. Revisit the solutions once if you want. Thank you.